We're going to calculate the difference quotient here for piecewise defined functions. And remember, this is our difference quotient in its general form. And this is for a in the domain of G, a plus h also in the domain of G, and of course h not equal to 0. And the value of this depends, because G is a piecewise defined function, depends on the value of A and the value of H. So this is also a piecewise defined function depending on values of A and H. We're going to calculate this for particular values of A and some limited values of H. And usually we're interested in what happens to this as h gets very, very small and very close to 0. So it's okay to think about this difference quotient for small values of h. So let's try to evaluate g of 0 plus h minus g of 0 over h, where g is given by this set of formulas. It's a piecewise defined function. And we want to calculate this for values of A which are relatively small. Their absolute value is less than 1, and they're not equal to 0. So we have some things to calculate here, g of 0 plus h. And now, how can we tell which category 0 plus h is in? We're going to substitute 0 plus h for x here. And the next step is to figure out what category 0 plus h is in. Well, we can simplify it a little. 0 plus h is just h. And the information I have about h is that its absolute value is less than 1 and it's not equal to 0. So it's definitely in this category. Minus 1 is less than h, which is less than 1 for sure. So h is in here for this particular, for example, A, or part A, and that means that g of h has to be h squared in this case. And how about g of 0? Well, that's relatively easy. 0 is also in this category, so g of 0 is 0 squared. And now g of 0 plus h minus g of 0 all over h is equal to, we figure this one out, it's h squared minus 0 all over h. So it's simply h squared over h, but h is not equal to 0, so I can cancel, and that's just h. So this complicated expression, g of 0 plus h minus g of 0 over h, is equal to h when the absolute value of h is less than 1 and h is not equal to 0. Now, as I said, the value of the difference quotient depends on both a and h. What if a is 1 and h is something greater than 0? So we're thinking about this difference quotient when a is 1. So we have g of 1 plus h here, minus g of 1 over h. And we're thinking about h greater than 0. Well, to calculate, I have to break it down. G of 1 plus h is equal to what? Well, to calculate g for any value where g is a piecewise defined function, I have to figure out which category this 1 plus h is in. Now, if h is greater than 0, this implies that 1 plus h is greater than 1. Since 1 plus h is greater than 1, and I'm going to substitute 1 plus h for x, 1 plus h is in this category. It's greater than 1, so g of 1 plus h is equal to 1 plus h itself, that's the x value, plus 1. This is my x value here. I'm substituting that for x in the formula, and that's because 1 plus h is greater than 1. So it fits in the category x greater than 1. Now this is equal to 2 plus h. And I also have to calculate g of 1 here. And I have to figure out which category 1 is in the definition. Well, 1 is in here. It's between -1 and 1, including the endpoints. So g of 1 is 1 squared. That's 1. And now I have g of 1 plus h minus g of 1 over h is equal to g of 1 plus h is 2 plus h. Substitute for that. Minus g of 1 is 1 all over h. So this equals 1 plus h over h. What about g of 1 plus h minus g of 1 over h, where the values of h are greater than -1 and less than 0? Now this looks the same, the formula looks the same, except the values of h are different here. They're less than 0. They're between -1 and 0. So let's see what happens here. G of 1 plus h is equal to what? Well, where is 1 plus h? If this is true, if h is greater than -1 and less than 0, then I can add 1 to all 3 parts of this double inequality by the laws of inequalities. And I get h plus 1 is between 0 and 1. So h plus 1 is in the middle category here. Remember our definition of this function. H plus 1 here is between 0 and 1, so it fits in this category. So g of h plus 1, or 1 plus h, is that squared. It's 1 plus h squared. And what about g of 1? Well, 1 fits in this category. We've seen that before. So g of 1 is 1 squared, which is 1. And now we can calculate this difference quotient. G of 1 plus h minus g of 1 over h is equal to 1 plus h squared minus 1 over h. And that is equal to, squaring this, 1 squared plus 2h plus h squared minus 1 over h. And this is equal to, I can pull out that h, and I get 2 plus h times 2 plus h over h. And because h is not equal to 0, I can cancel those, and I end up with 2 plus h. This is a very different answer than the previous one. So we have the same difference quotient, but we have different values of h. So when we're dealing with a piecewise defined function, we have to be very careful about the details when calculating this difference quotient.